Algorithm max min using divide and conquer. So basically what do you mean by divide and conquer? Whenever the problem is big, we divide the problem into k pieces and each piece is solved using same logic and we combine. If the problem is small, we solve. If the problem is big, we divide and solve. Let us solve the problem max min using divide and conquer. So what we write? So algorithm max min. Algorithm max min. So we have four parameters here. We have I, j, max and min. Assume that we have only one number. Then the same number is maximum and the same number is minimum. So what do you say? If I is equals to j. If this condition is true means what? If I is equals to j, then the same number is maximum and the same number is minimum. That means what? The smallest problem is having only one element, maximum and minimum both are same number. Assume that we have two elements. Then what will you do? Else. If I is equals to j minus 1, then what will you do? If I is equal to j minus 1 means what? We have two elements. The first index is 1 and the second index is 2. 1 is equal to 2 minus 1. The result is true. Then what will you do? We compare if a of I greater than a of j. If this condition is true means what? The maximum is equals to a of I and the minimum is equals to a of j. If the condition is false, of course, as usual, maximum is equals to a of j and minimum is equals to a of I. Is that clear? So assume we have one element, the same number is maximum and minimum. Here we have two elements, we will compare both. Assume that more than two elements if we have, then what will we do? Then we will do what? Else. The if condition else. Now what you do is very simple. We divide the problem into k pieces. How will we divide the problem into k pieces? Simple. We calculate mid is equals to low plus high by 2. So here low is what? I and high is what? J by 2. Then what will you do? You have two pieces now. I plus j by 2 will get two pieces. From I to mid, one piece, and from mid plus 1 to j, another piece. So what will you do? Simple. Max min of first piece, max min of second piece. Is that clear? So how will you solve max min of first piece? The first piece will be what? Assume that you have a piece like this. You have a big piece. Now this is a mid element. This is I and this is j. Then what will you do? From I to mid, the first piece, and from mid plus 1 to j, second piece. Right? So how will you solve? Very simple. I comma mid comma max comma min. So the first problem, first piece will get one maximum and one minimum, and the second problem is from mid plus 1 to j. Mid plus 1 j, but here max 1 and min 1. Right? Then the first piece you will get one maximum and minimum, and the second piece you will get one maximum and minimum. We compare both the elements. If max, if it is less than max 1, that means what? The first maximum will be compared with second maximum. If the condition is true, then what will you do? Very simple. Max is equals to max 1. Similarly, if the minimum and the minimum 1 will be compared, if minimum 1, if it is greater than min 1, that means what? The second minimum is minimum. Min is equals to min 1. So we got finally one maximum and one minimum. That will be the final answer. Is that clear? So this is about algorithm max and min, which is using divide and conquer. So in divide and conquer, what will happen? We check first the problem is, what is the problem? We want to find out maximum and minimum from I to j. So the smallest problem is we having only one element and we having two elements. If you have more than two elements, divide them into first piece from I to mid, the second piece mid plus 1 to j. Both answers are compared, max and max 1 and min 1, then you get the final answer. So can we take one example and check it how the problem is solved? Let's see. So assume you have something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 index, and the data will be 50, 30, 20, 40, 10, 25, 60, 55, 80, 90. Now initially what is the big problem here? I value will be 1 and j value will be 10. I value will be 1 and j value will be 10. 1 equal to 10 false. 1 equal to 10 minus 1, 9 false. Then immediately what will happen? The max min of 1 comma 5. So the problem is divided into first half and second half. Right? So the first half is having what? The first half problem is what? In the first half, the index number will be 1 to 5, and the second half will be having 6 to 10. Once again, this problem is divided into two pieces because it is having more than one element, more than two elements. Yeah. Here what will happen once again? Yeah. So it will be divided into 1 plus 5 by 2, 6 by 2, 1 comma 3 and 4 comma 5. Once again here more than two elements, we divide into further 1 comma 1 plus 3 by 2, 1 comma 2 and 3 comma 3. And here you divide into, so we don't divide further. Why? Because here you observe 1 comma 2, 2 elements, 1 element, 2 elements. Similarly, this also will be divided into two pieces. The first piece and the second piece. First piece 6 plus 10 by 2, 16 by 2. 16 by 2 is what? 8. So 6 comma 8 and 9 comma 10. 9 comma 10 is only 2 elements, but 6 comma 8 is 3 elements, 6, 7, 8. Once again we divide into 3, 14 by 2, 6 comma 7 and 8 comma 8. Now please observe very clearly, very simple here please. Now in 3 comma 3, who is maximum and who is minimum? In 3 comma 3, who is maximum and who is minimum? 3 comma 3. So 20 is the maximum and 20 is the minimum. Right? 20 is the maximum and 20 is the minimum at the place of 3 comma 3. And here in 1 comma 2, what will happen? 50 and 30. 50 will be the maximum and 30 will be the minimum. Now you observe, compare both maximums here. Max less than max 1, 50 less than 20, false. So the same number will be maximum. Now suddenly minimum greater than 20. So 30 greater than 20, true. So 20 will become the minimum in this step. So these two answers are compared and you got the final answer. In 4, 5 also